Okay, so this is lesson 3, estimate the value of the expression, which probably should have come before lesson 2, so you can figure out how to find the square root of numbers. But that's okay. We'll go through it and see how it goes. An estimate is an approximate calculation of a value. Estimates are useful when making comparisons or whenever the exact value is not needed. To estimate the value of an expression with an irrational number, first estimate the value of the irrational number, then calculate using the estimate. So an estimate of the value of pi squared to 2 decimal places, so to the nearest hundredth place. So the square root of 2, and I love that they have these little symbols right here. So obviously an equal sign looks like that. An estimation sign are 2 squiggly lines showing it's not an exact equal answer. So what we're gonna do is take 3.14 and square it. So 3.14 times 3.14. So the exact answer, and the reason why they have the 2 equal sign, or the equal sign there with the 2 straight lines, is because the exact answer of 3.15 squared is 9.8596. And then I'm gonna round that to the nearest hundredths place. So here's my hundredths place. I look to the thousandths place, that's a 9, so my 5 goes up. And the value of pi squared approximately is 9.86. So you can say pi squared, 2 squiggly lines equals 9.86, because that's the approximate. And also we are rounding pi to 3.14, so that's why this is estimated. Here, pi is estimated to be, or rounded to 3.14, because we know it continues on. It's a non-terminating number or rational number. So estimate the value of 11, the square root of 11 divided by 3 to the nearest tenth. So you're going to estimate the square root of 11 to the nearest whole number. So we've got this cute little thing right here. And so basically what that is if like we used our chart here, the square root of 11 falls right here, doesn't it? Square root of 11. So you know it's going to be 3 point something. It's in between 3 and 4. So they start here, 3.1 squared equals 9.61. So we're trying to get to 11. That's like our key number, right? So 3.2 times 3.2 is 10.24. 3.3 times 3.3 is 10.89. This is the closest to 11 because 3.4 times 3.4 goes over 11 by quite a bit, right? Now you could go even deeper like I did in that last lesson, and you could do 3.35 times 3.35, and that's not even as close as 3.3, so maybe like 3.33 times 3.33 equals, that's even closer to 11. But in this case, they're doing to the nearest tenth, which is totally fine. So we're rounding the square root of 11 to 3.3, this one right here. So then use estimation. The square root of 11 is rounded to 3.3 to complete the calculation. So 3.3 divided by 3, because you still have that part, equals 1.1. So the estimated value of the square root of 11 divided by 3 is 1.1. Between what 2 whole numbers does the square root of 20 lie on the number line? So we look back at our chart, and the square root of 20 falls here, which is in between 5 and 6. So between what 2 whole numbers? Between 5 and 6. And because the square root of 20 is a little bit closer to the square root of 5 than it is, well, no, sorry, it falls right here, between 4 and 5. Between 4 and 5. 4 and 5. Sorry, it goes up here. So, and because the square root of 20 is just a tad bit closer to the square root of 16, I would say it's less than 4.5. So I would say even like around 4.4 would probably be around the best estimation. Now, obviously, to check that, you could do 4.4 times 4.4, and that's pretty close to 20, which was our key, or what we were trying to find. And so that's how you kind of estimate those square roots that are not perfect squares. Estimate the value of the expression to the nearest tenth, the square root of 38 plus 8/9. Step 1, estimate the value of the square root of 38 to the nearest whole number. Find the nearest two perfect squares. So if I look at my chart, 38 falls between 36 and 49. 36, 49. So 36 is less than the square root of 38, but is greater than the square root of 30 or 49. 38 is closer to 36, so the nearest whole number, so if you look, here it is, it falls between 6 and 7. The nearest whole number is 6. So you estimate the square root of 38 to the nearest tenth. And 38 is pretty close to 36, so you know it's going to be, the square root's going to be pretty close to 6. So 6.1 times 6.1 equals 37, which is pretty close to 38. Now let's try 6.2. So, sorry, 37.21. And then 6.2 times 6.2, 38.4. 44. To the nearest tenth, the square root of 38, I would go with this one. That's closer than this one, 6.2. Estimate 8/9 to the nearest tenth. So 8 divided by 9 equals, that's 8 repeated. And then don't forget, this is what we're doing is adding. So 6.2, oh, we rounded, it gets rounded to 9. Because it's 8 repeated, we're rounding to the nearest tenth. So that 8 becomes a 9. So then 6.2 plus 0.9 equals 7.1. So the estimated value is 7.1. So to like really write this out as an equation, you would have those two squiggly lines to show it's an estimate. All right, the circumference of a circle with the radius r is given by the expression 2 pi r, or 2 times pi times the radius. That's the circumference. The circumference of a circle is the distance around. Here's the center, there's the radius. So if I take 2 times pi times the radius, I'm going to get this circumference, or what the distance around this is. And it works for every circle. Choose an estimate for pi, then multiply. So estimate pi to the nearest hundredth. We know it's 3.14. Multiply 2 times 3.14 times what we're assuming this is the radius. Oops. The radius is 7.05. So 2 times 3.14 times 7.05 equals 44.274. Rounded to the nearest hundredth is 44, 27 hundredths. So the circumference of the circle is approximately 44 and 27 hundredths of a centimeter. What is an estimate? So it is when you round numbers and do the operation. It's an approximate answer. What is the process for estimating the square root of a number that is not a perfect square? Find the perfect square it falls between. And then start kind of like rounding. So like if you had the square root of 82, so you know it falls between the square root of 81 and the perfect square of 81 and 100. But because 82 is so close to 81, you know your square root is going to be between 9 and 10, right? But because 82 is so close to 81, you know it's going to be closer to 9 than 10. So it's going to be like 9.1 or even 9.05. But then like if you had the square root of 99, obviously that's closer to 100. So you know your number is going to be closer to 10 than to 9. It's still going to be 9. Your whole number is still going to be 9, but it might be like 9.9. And that's how you kind of estimate to figure out. And obviously there's the fun square root button on your calculator. So like 82 square root, 9.05. And then the square root of 99, 9.9, yeah. All right, so then you're gonna go ahead and do that. Estimate each square root to the nearest 10th. If I were you, I would write out this perfect square chart here, or just list them out so you can kind of figure out where they go between. And it says estimate, so you're not using your calculator. Now you can use your calculator to do the actual multiplication, but what I mean by that is like the square root of 22 falls between the square root of 25 and 36, so you know it's gonna be 5 point something. And you know it's gonna be a little bit closer to the square root of 25, so it's gonna be closer to 5 than 6. So what you wanna do to actually do the estimation, now you can use a calculator for this, but you're gonna do like 5.2 times 5.2. Now that's 27. Oh, sorry, I keep doing this wrong. So it's gonna be 4 point something. The square root of 22 falls between the square root of 16 and 25. Yikes. So you know it's gonna be 4 point something. And the square root of 22 is closer to 25 than it is to 16. So you know it's gonna be over 4.5. It's gonna be closer to 5 than 4. So I'm gonna try 4.6 times 4.6. And our target number is 22, and I have 21.16. So let's try 4.7 times 4.7, and that's 2209. So that's pretty close. So my estimation is 4.7 because we're going to the nearest 10th. And then the square root of 59 falls between the square root of 49 and 64. So we know our number is going to be 7 point something. Now 59 is closer to 64 than it is to 49. So you know your the square root is going to be closer to 8 than 7. So it's probably going to be over 7.5. So I'm going to try 7.6 first. 7.6 times 7.6 equals 57, and our target number is 59. So now I'm going to try 7.8. 7.8 times 7.8 equals, that's pretty close. I'm going to go down to 7.7 just to see, 7.7, and that's even closer. So I would say my estimated is 7.7. And so you're going to go on and try these along with the word problems. And then for the other side, now if you look at this, these are really cool equations. So if you see this right here with a number right in front of a square root, that means multiplication. So you're gonna find the square root of 5 to the nearest 10th and then multiply it by 4. So let's go ahead and do that one. So the square root of 5 we know is in between the square root of 4 and 9. So the whole number it's between is 2 and 3. The square root of 5 is closer to the square root of 4, so you know it's going to be less than 2.5. And I think we did this one, but let's just see. So 2.1 times 2.1 equals 4.4. So let's do 2.2 times 2.2, and that's a little bit closer to 5. 2.3 times 2.3. Was that closer? So we've got 5.9, and then 2.2 times 2.2, 0.84. Oh, those are both pretty close. So this is 16 away from 5, and this is 29 away from 5. So this is actually closer. So I'm going to round that to the nearest 10th, which is 4.8. So this is 4 times 4.8. So the total answer is 19.2. So the whole point of this is not to use that square root button. It might be tempting to use. The whole point is to estimate those. So to try and come up with what the closest estimation is for the square root of a non-perfect square, and then to do the rest of the work. So go ahead and practice using the rest of these problems, and Google chat me or email me if you've got any questions about it. This is really tough work. But if you list out your perfect squares and you just use your rational thinking about which whole numbers it falls between, and then use a calculator to help you with the squaring the number, it shouldn't be all that tough. But obviously, let me know if you have any questions.